Hello friends, and today later we are going to discuss about the next topic of machine learning, that is concept learning. So what is a concept learning is? The concept learning is a subset of objects. Like this is the object, things which exist in the world, any events. So in this objects, the particular set, when you are studying it, you are analyzing the learning of this particular set. Like consider this is birds, this is animals, this is car, something else object. So this is concept is a subset of object, events defined over the large set. For example, that we refer as a set of everything. This object is everything, all object. The animals are the subset of one thing. The birds are the another subset of animals. So here, more technical way we can define it here. A concept is a Boolean valued function over this large set. What it means here? Consider this example is given here. Overall, this animals whose value is true for the birds and false for the every other animals. So that result is always either in form of discrete values 1 or 0 will be there. Like we can take the example here. Consider we having the database like this. This one database we having. Now we are learning about the concept of machine learning point of view. This is database is given here, and this attributes, this sky, air temperature, humidity, wind, water, forecast, and their value is given here: sunny and rainy for the sky, air temperature warm and cool, the humidity is high and normal, wind is strong, maybe weak also, that water warm, cool, and that forecast is same, changes. That is the value of this each attributes is given. And based on these attributes, whether you will decide the particular day where the is good day for the enjoying the sports. So here we can say that the concept is good day. We are deciding the good day for the water sports. For the particular day, whether the day is good for the water sport or not, we are deciding it. So that is discrete value based on the days, based on these attributes. You can check out whether the particular day is good, whether or not, like weather conditions, and decide whether this particular day is a good day for the water sport or not. So this the values of this concept is either will be yes or no. So this is called as concept learning. So here the value is given, which is a sky is this sunny and rainy. So I will write it over here. A sky value is sunny or rainy. So these are the attributes and its value is given over here. So a sky having two values, sunny and rainy. Similarly for the air temperature, humidity, wind, forecast and water. So these are the attributes and values given. So now consider if you given the statement here. The statement here given, if air temperature is cold and humidity is high, then so check out whether this is the good day for the water sport or not. If the temperature is air temperature is cold and humidity is high. So here we can see that here air temperature is given for the cold. So air temperature is cold and humidity is high. So whatever the another attributes, reason that sky is rainy, yeah, another attributes if not given also, but we know that these two attributes, the air temperature is cold and the humidity is high, this particular day, the enjoy sports is not a good day. Okay, so that enjoy sports is a no here given here means this particular day it is not good for the water sport. It is not good day for water sport. Okay, so what it's mean here? So we have to find here all the best concept descriptions of all whatever the data is given, the set of all possible hypotheses. Best means which is more generalized, yeah, more known, yeah, unknown is given at the particular elements of instant space. So here we can write it here. The most general hypothesis is every day is a good day. We can assume that every day is a good day for water sport. So we are not considering any attributes values here. So not considering here, so I can write it how many attributes is there, totally having the that 6 attributes. So all attributes values I am marking with question marks because we are not considering anything here. All the 6 attributes is question mark because we are considering every day is a good day for the water sports, but that is depend upon the value of attributes. And in this case, first case, we are considering it every day is a good day, which means we are not checking out the value of attributes, means still we have to decide. That's why this whole values of these attributes values is question marks. This is most general hypothesis. We also called as generic hypothesis. Now we have to reach till the most specific hypothesis, which is no day is good day for water sport, and we'll mark it all these attributes as a 5. So all this most specific hypothesis, all the attributes value will be 5, and most generic hypothesis, all the attributes value will be the question marks. So we'll first initialize as a no days is a good day for the water sport, and you have to reach till the day which is having the good day for the water sport. So here we have to convert this collection of data whatever is given here, convert the collection of hypotheses into a form where they indicate the result of the task forming very specific task to general task. Yeah, you can say that we have to convert this most specific hypothesis to the most general hypothesis. So for converting this most a specific hypothesis to the most general hypothesis, we having the algorithm called as apply that S algorithms. So we'll discuss about the algorithm of finding the S algorithms. So mainly the task of the find S algorithms is to find the maximally specific hypothesis in the form which that satisfy all the given hypotheses for the required result. So only the find S algorithms only consider that positive results in favor of the positive result, and it will ignore the negative result. So what is a positive and negative result? Here I will explain with example here. First we'll learn the algorithms here. First we have to initialize hypothesis H to the most specific hypothesis. In H. The most hypothesis, as we discussed here, all we have to indicate all the value of attributes is 5. This is the most specific hypothesis. Now this is step 1. Step 2, for the each positive training, instance X. So for the each positive training, the instance X, and for the each attributes constant you have to go check out, and then if the last hypothesis and the next hypothesis attributes are same, then you have to do nothing. If the attributes of the same values as the hypothesis 1, then do nothing. Else replace the values of this X by the most general constant, which is question marks, satisfied by the X, and finally the overall hypothesis. Let's see the example here. So I will explain now. So here first one, we have taken the example for these tables. This sunny, sky, sunny and rainy is the attributes here. So I will write it all the this attributes here. X1. X1 is sunny, warm, normal, strong, warm, and same. Yes is a positive result. Means we want to check out whether the particular day is good for the sports or not. So if this condition holds at the particular day, then that particular day is a good day for the enjoying the sports. So this is yes, it's giving here means positive result, which is giving no here, that is negative result. So I have to check out the particular day is a good for day for the enjoy the sports or not. So we'll take yes as a positive remark and negative as a no is a negative remark. So here X1, we can write it, that is sunny, warm, normal, strong, warm, and same. So these are the values here, and this is giving the positive result. So I will remark it is here. This is positive. Similarly, I can write for the all. So these are the X1, X2, X3, and X4 are the 4 these values of this particular attributes, each attributes, that sunny, warm, and so on I have written, and which is yes, that I mark it as a positive remark, and which one is no, that is negative. So now we have to solve it by using the find S algorithms. So first we will consider this like a hypothesis H0, as we discussed in the algorithms. Initialize the most specific hypothesis in H. which is all are null, that is 5. So I will write H naught, which is all are 5. So this is the step number 1. Now for the next hypothesis H1, for the positive training, we have to check out for the each attributes constant of x in H. If the attribute has some values as the hypothesis 1, then do nothing. Else replace x by the next general constant satisfied by x. So here that is the question marks, right? This is the question marks. The next x1 which we got it here for the x1, that day 1, that value is sunny. And sunny is not same as a 5 here, so I will write it. Similarly for the worm also you have to write it, everything is not same as a 5 anything, so we'll copy it all the values, at normal, strong, warm and same. So this one is the first hypothesis H1. Now for the H2, we'll same continue here. If the attribute has the same values, then hypothesis 1, then do nothing, else replace x by the most generic. If not same, then you have to replace with the most generic constant, which is question marks. So here, if you second attribute x2, you have to see sunny and sunny is same. So I will do nothing, means copy it. Here warm and warm, here also is same. Now here this is normal, this is high. So here is changing, here is not same. So we have to replace with the most generic forms, which is question marks. So this one I will mark it question marks. Next, this strong and strong is same. So I will write as it is, do nothing. Warm and warm is same. So I will write as it is. When both are same, you have to do nothing. Next, same and same also is write as it is. So this is the second hypothesis. Now for the H3, we have to compare with this one, X3. So here if and this one is negative. So I told you in the beginning that this Findess algorithm is only applicable for the positive result. If negative result is there, ignore it. Means just you have to copy it. Whenever the negative result is there, negative classified is there, no changes will be happen. So no changes will be happen, then this will be same as a H3 will be same as a H2. Have to not compare because this is the negative result. That warm, question marks, strong, warm and same. Now for the next hypothesis H4. This is positive, so I have to compare it. That sunny and sunny is same here, so I have to do nothing. That is warm and warm is also same, so do nothing. That question marks and high is also different here, so you have to write more generic only question marks. That strong and strong is also same, so I write strong as it is. Now here cool and warm, again here it's changing here, so you have to replace with the most generic, so which is question marks. And here changes and here same, here also question marks. So these are the 4 hypotheses will be there, and this is the use of Findess algorithm.